Let's go ahead and do some area of sector problems that are more wordy. In the last examples, I just straight out gave you a radius or gave you a central angle, and we did the math. But here, what we have is a word problem. And again, the area of a sector is 1/2 r squared theta, and we have to be in radian mode in order to use this. So the first problem is asking us to find the central angle of a sector that has an area of 20 feet in a circle of radius 4. And then, of course, round your answer to the 4 decimals. And again, I'm kind of keeping that on the back burner since we're going to be focusing on fractions. So basically, the idea is we have everything we want. The area, right? So if we just write our formula down and substitute, we know, right? The area is 20. Half is a half. The radius is 4, right? And we got to find our central angle. So essentially we have everything we need. I think if we do the math here, we get half of 16. So we get 20 equals 8 times theta. If we divide both sides by 8, and if we reduce our fraction, I believe a 4 goes into there twice and in there 5 times, what we get is 5.5 radians, or 2.5 radians is what we have for an area of 20 feet of a circle that is radius 4. So there's our formula. There we are solving it, plugging things in, and doing our fraction work. Okay, so that's how I want to see things done. Again, I'm kind of temporarily suspending that 4 decimal accuracy. Well, actually, let me bring it back into play here. Follow my own rules. Right, there's a couple of decimals in here, so rather than pushing that more complicated fraction around, we will turn to technology. But I'll try to do it to the bitter end. So in this case, we already know the central angle is pi over 3, and we know that the radius is the area is 12.75. So our formula is this. My area is 12.75, and we've been told that that's pi over 3. So again, I'm going to keep working on fractions as much as I can. This is pi over 6 r squared. So if I take both sides and multiply it by 6 over pi, we essentially get that r squared is 6 times 12.75 all over pi. When we take a square root, technically speaking, there's a plus minus, but since we're talking about the radius of a circle, right, we're talking about the square root of 6 times 12.75 all over pi. So there's about an exact answer as I can get, but let's go ahead and we'll round this off a couple of decimal places. Let me go ahead and try to get that wicked glare off of there. So again, my TI calculator is still kind of on the blitz, so let me go ahead and use this tool. So I'm going to first, how about we take 6 and we're going to multiply it to 12.75, right? That'll give us 76.5. I'm now going to divide that by pi and get that answer, and then I'm going to take its square root. So I have a nice square root feature right here. Right, and so oops, I goofed up. So what did I do wrong here? So let me clear this up. I guess I have to take the square root, right, of 6 times 12.75. Oops. I hope this is going to work. I probably should use some parentheses. So square root, parentheses, 6 times 12.75, right? And we're going to divide that by pi, and let me close my parentheses. So that should give us a pretty good value. So 4.9346. So R is roughly 4.9346, and this would be measured in centimeters. Okay, so there's our use of our formula. In a more wordy problem, again, it's just figure out who's who, plug it in, do the math, right? Do the algebra, solve for the variable, and then in this case, we kept it as a nice, neat fraction that it is. Here, because of that crazy decimal, we went ahead and turned it to for decimal accuracy. So please follow suit. I do believe on the quizzes I'm asking for exact fractional answers. So again, I'm kind of forcing the issue with fractions because we need the work. You guys can do it. Let's get better at it. It's going to help us in the future, not only in our class, but in your future math classes. All right, the better you are at fractions, being able to simplify them, solve equations with them, the better math student you'll be, and you'll have more success. All right, so you can get mad at me now, but hopefully you'll thank me someday. That wraps up Section 3.2, our two major applications, arc length and area. And so that's all we have scheduled for the week as well, so kind of a nice short week. And then we'll hit the ground running. We'll finish Chapter 3 in the following week where we do more applications with radians. I'll see you guys then. If you have questions, please ask. Jump on Canvas and show me your work. Email me, visit me for office hour time, whatever it takes to help you learn the material. Talk to you guys later.